math, we use relationships between quantities to describe patterns and solve real-world problems. Linear relationships and functions help us predict what happens when one quantity changes. Learning these keywords in 8th grade will make it easier to understand, graph, and work with these relationships. Some quantities change together in a predictable way. Let's learn the different kinds of relationships. Proportional relationship. A mathematical relationship between two variables where their ratio is constant, meaning they change at the same rate. This relationship can be expressed as the equation y equals kx, where k is the constant of proportionality. For example, if a taxi charges $4 per mile, the total cost is always 4 times the number of miles. Constant of proportionality. A fixed, non-zero number that shows the unchanging ratio between two variables in a directly proportional relationship. In the taxi ride example, $4 per mile is the constant of proportionality. Non-proportional relationship. Two quantities that do not change at a constant rate. Their graph does not go through the origin. Linear relationship. A relationship between two quantities that forms a straight line when graphed. We often express this in the form y equals mx plus b. An example would be the distance traveled at a constant speed over time. Nonlinear relationship. A relationship between two variables that when graphed does not produce a straight line. For example, the height of a bouncing ball over time. It goes up and down. Functions are a special kind of relationship where each input has only one output. Function. A rule that pairs each input to exactly one output. We often represent them in 3 ways, with a function map, an input-output table, or a rule. Key characteristics of a function. Functions have a domain, all the possible inputs, and a range, all the possible outputs. They can have intercepts, increasing or decreasing intervals, minimum and maximum values, and specific end behaviors. Properties of a function. Every input has exactly one output. Functions are defined by their domain, range, intercepts, symmetry, and behavior. The vertical line test can confirm if a graph represents a function. Every function has limits on its inputs and outputs, called the domain and range. Domain. The set of all possible input values. For example, the number of hours you can work in a week, 0 to 40. Range. The set of all possible output values. For example, the money you can earn in a week if you earn $10 per hour, 0 to 400. We graph relationships using a coordinate plane with 2 axes. Horizontal axis. The x-axis on a coordinate plane. It runs left to right. The first value in an ordered pair represents how far along this axis one moves. The point 32 means move 3 units along the x-axis. Vertical axis. The y-axis on a coordinate plane. It runs top to bottom. The second value in an ordered pair represents how far up and down one moves along the vertical axis. The point 32 means move 2 units up the y-axis. Intercepts are the points where a graph touches the axes, often helping us identify starting values. X-Intercept. Where a function crosses or touches the x-axis. It is represented by the coordinate x, 0, where x is the x-intercept. It is also known as a zero, a root, or a solution of the function. Y-intercept. Where a function crosses or touches the y-axis. It is represented by the coordinate 0, y, where y is the y-intercept. It is represented by b in the equation y equals mx plus b for linear functions. Initial value. Another name for the y-intercept, showing the starting amount when x equals 0. If you start with $5 in a savings account, the initial value is 5. Slope tells us how steep a line is and how one quantity changes compared to another. Slope, the ratio of how much y changes compared to x, also known as rise over run, and is calculated with the formula the change in y divided by the change in x, which equals y sub 1 minus y sub 2 divided by x sub 1 minus x sub 2. Rate of change. Another term for slope. It describes how one quantity changes in relation to another. Linear functions can be written in different forms, each useful for identifying specific features like slope or intercepts. Slope-Intercept Form. Y equals mx plus b, where m is the slope and b is the y-intercept. Point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1, where m is the slope and one point is x sub 1, y sub 1. Standard form. Ax plus by equals c. This is just another way to write linear equations, where a, b, and c are numbers.